So in this video, we're going to go through an example of classifying data into the various different types. So the data we're going to be working with is a sample of 40 athletes competing in the local mixed soccer competition. For each of the variables that's been collected about them, we need to identify the data type as either qualitative or quantitative, and then the subtype as either nominal, ordinal, continuous, and discrete. And I've popped up here the kind of flow chart in terms of the categorization. If you want some more detail around that, go back and review the recap video. So this here is just a section of the data that we're working with, and you can see we've got a few different variables that we're going to need to classify. Should mention this first column here, it's like the observation number, so just counting up how many people really have been surveyed. So this column doesn't need to be classified because there's no real analysis that you can do on it. So the first one we're going to be working with is gender, and I'm going to fill out this table here. So the first decision we need to make is whether gender is qualitative or quantitative data. So we can see that there's really two options that people are identifying with. Either people are answering as female or people are answering as male. So this would suggest it's a categorical type of variable. You're either categorized as a female or a male. And what we know is that categorical data is a qualitative data type. So that's what gets popped in here. And then from there, it branches off into nominal and ordinal as the two possible subtypes. So the real difference here was just whether the categories had an order associated with them or whether they didn't really have an order associated with them. And I would argue for gender, there's no real order, so that would fit into a nominal subtype. You know, we can't say that male is better than female or that female is higher than male. It just doesn't make sense. So that's why I spelled that wrong. That's why it ends up as a nominal variable. Alright, so the next variable to work with is club. So what we can see here is that people have answered with various different team names or club names. And what this would suggest again is the words kind of are a giveaway, that this is really a categorical variable. You're either categorized as a Bears person, a Cowboys person, a Vikings person, and so on. So if it's a categorical variable, that means that it's qualitative data. And then we need to choose whether it's nominal or ordinal. So I would suggest again that we're on the nominal side of things, simply because there's no natural order amongst these categories. Again, we can't say that Bears are better than Cowboys or Vikings are higher than Eagles. It just doesn't make sense. So that's what goes in here. Alright, the next one is division. So we can see that people are listing their division as A, B, C, D, E, and so on. So this again represents a categorical variable. You're categorized as either being in Division A or Division B or Division C. So we can pop that in. And then the next decision we need to make is whether it's nominal or ordinal. Now this time I would suggest that there is a natural order among these categories. Presumably Division A is better than Division B and Division B is better than Division C. Okay, so there is a natural order amongst those, which would suggest that we have an ordinal type of data. Alright, next up we have the number of games that people have participated in. So this one here, it's a number, which again can be a bit of a giveaway. That's like numerical data, so that would suggest it's probably going to be quantitative. Alright, so then we have two options, continuous and discrete. So continuous is when you have like an infinite number of values that it could take, and discrete is when there's a fixed number of values that your observation could take. Now for this, I would suggest that there is a fixed number, because if we're measuring the number of games that someone's participated in, it really is going to be a whole number. You've played in 1 game, you've played in 6 games, you've played in 20 games, and so on. So therefore, if there's a fixed number of observations, or fixed number of values I should say, that it can be, then it's going to be a discrete type of data. Alright, moving on to the next one, so height. So this one, we can see again, it's numbers that it's being measured in. So that would suggest it's numerical data, making it quantitative. And then we need to decide whether it's continuous or discrete. So this time, if you think about someone's height, really all that's limiting you in how many decimal places you measure that to is the tool that you're using. So if you're using a ruler, maybe you can only get to the nearest centimetre, but if you're using a more accurate measuring technique, then you could measure this like theoretically to essentially an infinite number of decimal places if you had the tool to do it. So therefore, this would be a continuous type of data. All right, so that's what's going to get popped in here. All right, the last one is the weight, and this one's very similar to height. Again, I would say it's going to be quantitative because it is measured in numbers or numerically. And then with regard to whether it's continuous or discrete, I would argue that it's going to be continuous. Again, someone's weight can have like an infinite number of values. You know, we can have 87.654. It could be, I don't know, somewhere in here, 72.5984, whatever. You can measure it with an infinite number of decimals if you have the measuring capabilities. So therefore, it's going to be continuous. And we've finished filling out our table. So that's all there is for that video, and I'll see you in another one.